Okay, we're finishing up chapter 1 with lessons for section 1.3 and 1.4. Just go through these briefly. Reading your book in more detail will really be helpful if there's something you're not quite familiar with or need more details with. But basically, one thing we want to talk about too is answers and rounding off. So we always want to round one more decimal place than was present in the original data. So only round the final answer, not in between items. And you've probably had some lessons on that already, but just a refresher. Levels of measurement that we want to talk about are nominal scale. That's when there's labels, you're categorizing things. It would be stuff like maybe brands that you are talking about, different kinds of things, or TV shows or something, but you're not giving any kind of weight or order to them. So that's just a nominal scale of measurement. Ordinal scale is we're going to add ranking into that, or first, second, and third, we have ordinal. Interval scale is a little bit tricky to differentiate sometimes from ratio scale. So interval would be like temperature. There's no true zero, that it doesn't mean absence of something. Like think Celsius. 0 Celsius doesn't mean nothing is happening, or 0 degrees is nothing happening. There's you can go below or above that, and it doesn't make sense. Like you wouldn't say that something is twice as much or 4 times as much. Where ratio, you can certainly do that. So there's multiplication and division could be happening on those. So just try to do your best. In the My Open Math, you might have some that it's a little vague to tell, but you get those second attempts and you can retry a new problem. So you'll get the gist and the differentiation. And if not, let me know and I can help you out. So we're going to look at example 1.6. 1.16. A study was conducted to assess school eating patterns in high schools in the United States. The study analyzed the impact of vending machines and school policies on student food consumption. A total of 1,088 students in 20 schools were surveyed. Determine the level of measurement of the following variables considered in this study. So based on what you saw up here, and I'll shrink this down a little so in case you don't have your workbook there in front of you, you can see them. So we have nominal, ordinal, interval, and ratio. So A is the temperature of a cup of hot chocolate every 15 minutes until it reaches room temperature. So which one do you think that is? So you can pause the video and think about it. B is whether or not the school has a closed campus policy during lunch. And C, class rank, freshman, sophomore, junior, or senior. So we're just saying, which scale is it? Is it the nominal, ordinal, interval, or ratio? We also have D down here, number of days per week a student eats school lunch. And I think that's the last one. So pause and think about what you want to write, and we'll see how we match up. Okay, so hopefully you had a chance to think about it. A, the temperature would be interval scale. B is just a yes or no kind of thing, so that's nominal scale. C is ranking, so that's ordinal scale. And D is number of days per week a student eats school lunch, think you could, you know, doubling that would make sense or something like that. So I'll jot the answers here in red for you. Okay, so there's your answers. And next we're going to look at frequency and how we use that. When data is collected from a survey or a designed experiment, they must be organized into a manageable form. Data that is not organized is referred to as raw data. Data can be organized using tables, graphs, and numerical summaries. So when we do some of our activities, I'm going to say, I want you to collect raw data, go on the internet, find some raw data, or I'll give you a raw data set. That's what I want you to use, not a pre-done graph. Sometimes you will be looking at pre-done graphs, but a lot of times we'll be wanting to learn the techniques to make the graphs and stuff. So I'll guide you to how to find raw data, but mainly I'll be providing it or a link directly to it and show you how to use it just for time's sake. Okay, so it can be pulled off a spreadsheet of some sort or listed in, copy pasted, even in your MyOpenMath, and I'll show you how to do that too, so that you can just put it into either Staplet, GeoGebra, Excel, some of the software that we use. So a frequency distribution is when we just have the number of occurrences. Cumulative frequency is kind of totaling up like the prior one, adding on each time. Relative frequency is when we have the ratio. It's either fraction or proportion, or, you know, could be as just as a decimal. So those are nice to have because it's pretty meaningful to know how they relate to one another if you're kind of comparing apples and oranges, so to speak. Cumulative relative frequency is the same thing. You're just adding the prior one. So we'll show some examples of that as well. Example 1.17, the following data represent the number of available cars in a household based on a random sample of 50 households. Construct a frequency and relative frequency distribution for the given data. Use 2 decimal places when rounding if need be. So we have this chart here. Let me make that a little bit bigger. Okay, so if you have the workbook, you can just, you know, easily see it there and work with it. But if you are just looking at the screen, I'm gonna make sure you can still see that and fill in the chart. And you can just draw the chart on your own. You don't have to rewrite everything unless you want to. So over here we have number of cars, and then the frequency, cumulative frequency, relative frequency, and then cumulative relative frequency. So we're going to fill in over here on the left, we're going to put, if we had 0 cars, like, so we can see they go from 0 and the highest one is 4. So we want to fill in our chart, and we're going to put in, this might be a little hard to see at first, 0 there. And I'm just going to try to center that. So I'm going to let you fill it in. I'll go across ways first and just show you how it would be, but it would be the same thing for each one. But since I have to type it up, I'll pause and do that. You don't have to watch all that. But the frequency that 0 happened, I can just count here. So if I had paper, I would like block them off, but I'm just gonna be careful and make sure I don't do duplicates or miss any. So 0, So I would have 1, 2, 3, and then I have to kind of look 4. So that's one way to do it, that I could, then write in the 4 here. That happened 4 times. Okay, so getting that in there. Another way I could do this is to list out all my numbers. So I would have 0, 1, 2, 3, 4, right? And then as I go, I could use the tally system. I could tally, okay, I have a 3, I have a, and I could tally it up. So then that way I don't miss any. Or you could kind of use different highlighters. However you want to track that is up to you. So go ahead and pause the video. This is, remember, it's not just example notes and lecture. It's more interactive, that you're working along with it and completing things. I'm just giving you some guidance to get started. So I'll do the first 2 columns, make sure we're all on the same page with that, and then show it. So pause the video and you work that out. Okay, I think I wasn't looking that carefully to start with, because we do go up to 5 cars. So that's why there's 5 rows. So this is what it should look like. Frequency should be 4, 13, 22, 7, 3, and 1. So you can kind of tell, like, oh, just looking at the table, that gives you a good idea. But when we take that and then put it in a graph of some sort, that's even better for like a quick visual. And sometimes we really want to just see the tables. So again, raw data is up here, and this is a table. We're doing a clumped up one with frequency, cumulative frequency, relative frequency, and cumulative relative frequency. So for the cumulative frequency, we would start with 4, and then we would add on what we had prior. So this one is going to be 4 plus 13, and so we're going to have 17 there. Okay, and you don't need to write in all the math on that. You can just kind of do it in your head. I'm just doing it here to show you so you can get the gist of how it should work. And then again, the next one, we would then add on. We would have our 17, and we would have our plus the 22, the new one, and we would have that equal 39, and so on and so forth. Okay, so I'll let you fill those in. I do want to show you relative frequency though. So you can go ahead and do that one as well. So relative frequency, you're taking the number, which is 4 here, and you're dividing it by the total, which is 50. Okay, and then you could write it as a reduced fraction, or you could just do it on a calculator and get 0.08. A lot of times we want to write 0.08 just so it looks nice and tidy and proper. You could also write that as 8%. Okay, so that is an option there. Okay, I've gone ahead and filled in the next one too. So we would have, make sure you do go back to frequency. Usually I like to have the frequency and relative frequency next to each other is nice, but you would go back to 13, divide by 50, and you would get 0.26. If I did relative, cumulative relative frequency, I would just add the 0.08, the start one, add the 0.26, and then get 0.34. So I think you get the idea with how those work. So we can go ahead and fill in the chart real quick. Okay, so go ahead and match your answers up with mine. And when we're thinking about things like the relative frequency and cumulative relative frequency, we're going to use those later when we are working with probability. Now we're going to look at class intervals for large data sets. So that's a way we can organize the data. Usually we have somewhere between 5 and 20 classes, depending on the number of data. They should be equal in size. So we don't want sporadic widths. And we want to contain all the data in the set. So we would find that by getting the range, largest minus smallest value, divide by the number of class intervals. And so we want to have at least 5 and no more than 20. And then round up is what would work in this case. A lot of times we use the midpoints when we're graphing the quantitative data, and we can just take the average of the lower and upper class limits. We'll do this for histograms and things, but right now we're going to look at the frequency tables and just making a table with it. So here is the total cost of textbooks. So this is example 1.18. So it's collected from 36 students. Create a frequency table with 8 class intervals. So if we have 36, I'm going to take and figure out our class range. And divide that by the number of intervals. Okay, so we have to look at our lowest. Find that on here. Looks like 140 is the lowest. Hopefully they're in order. Yes. And the highest is 459. So we want to fit everything in there. So you're going to go ahead and subtract those two and divide by the number of intervals. So go ahead and do that. So to figure out our class range or our, width there, we're going to take and subtract the 459 minus 140, got 319, divide by the 8. And we get 39.875. So make sure you round up so you can include the last bits of it. So round up to 40 for your width, or they're saying range here. But so that means starting at 140, 140 counts as the first one. So you're not just going to say 140 plus 40 goes up to 180. We would include 140 in that count. So when we fill up our widths in here in the chart, you want to make sure you actually write it as 140 to 179. Okay, because that 140 counts as a value. And then we have 39 more, so that makes 40 total. And then the midpoint for that, we would just take the average of 140. So we would just go 140 plus 179 is 319 divided by 2. And we get 159.5, and we're going to round up. So that would be 160. So we want to get that in there. And then the frequency that happens is going to be, we're going to count up. We're going to look at for all the numbers between those values. These are sorted in order, so that's helpful. 140, so we have 1, 2, 3, 4 of them. So we would have 4. And then just repeat for the next row. So when you do the next row, you want to make sure you put in 180. Don't start with the 179. You're going to go 180 to 219, and the midpoint would be 200, and frequency is 1. And you can catch the midpoints. You don't have to actually do the average out of these every time. You can just be adding. In this case, you can add 40 on each time. And then you'll see a pattern here that you can be doing that also. If you add 40 to these, 40 to these, it makes it work out quite nicely and simply. So we show you how to do that table by hand, just when you have small data sets and you kind of understand how it works. But then we're going to use technology, and you'll just actually throw your data into the technology. You'll hit to make a histogram or a table or whatever it is, and it's so much quicker and nice. But I think it helps people to understand how they're sorted out, what the width means, and you get some of that general understanding in a better way by seeing it manually done and actually doing it. So go ahead and fill out the remainder of this table. So pause and then match up your answers with mine. Okay, so you want to pause and just make sure you're matching up. Okay. And so you can see the clump that has the most is the 300 to 339. Even just from the table helps sort it out really well. Remember, this is total cost of textbooks for the term, data from 36 students. And section 1.4 we will do in a next video.